Hello YouTube, here is part 2 of my CNC lathe, and I'm happy that I got to it today before sun went down. I still had to turn on my light to get better lighting. Anyway, it did quite evolve, and I don't even know where to start. Well, let me start with one thing. There is no backplate. Of course there will be one, but the only place I found a backplate ready machined, just ready to be welded onto the shaft, is in the UK, but unfortunately that company insists of sending it to me with DHL, which sucks big time in Bulgaria. And I have to deal with them. It takes about 1 week to let them know what am I getting, and then I have to drive 80 kilometers, about 50 miles, to pick up the package after going to the broker, bank, customs and the DHL office, obviously. And it cost me an additional about $50–60 to do so, plus I lose at least half a day of work, well, time. And I don't know what I'm gonna do, if I'm gonna still buy from them, because originally I was gonna use a dumbbell weight and turn it down and whatnot, but I just cannot see it putting on this machine. It just looks too nice to be putting a turn down dumbbell on there, even though at the end it wouldn't be visible as a dumbbell. Anyway, so there will be a backplate, obviously, so that's the first thing. Secondly, since this thing went higher than I thought it would, I did raise the whole headstock by 25 millimeters by these solid aluminum, what they're called, I don't know. That's what they are. These I had bought, this is 40 millimeters, or 30. These I had bought from Germany, and for my CNC mill that I built 5 years ago, and these were leftovers. And so that was just a perfect fit. It was too long, I had to cut it down, no problem. And so I did raise the headstock. And I did put in a 80 by 80 profile in here as well to have it, and as you can see I'm covering everything up that I can. So this headstock is not just these two, but this is all screwed together, obviously, down to each other and anywhere I have slots. So this is as rigid as it will get. This will not go anywhere else. And I'm still waiting on my new belts that I ordered, because the ones I ordered were wrong. I did mount the spindle. This is where the stepper goes. That's a 111 millimeter stepper, NEMA 23. This will go over pulleys again to the ball screw for the carriage. And I actually figured out a way to exactly measure the distances that I need from here to here, from here to here, from here to here, by using my beloved program Eagle. And let me actually take this out of here. And sorry for the shaky video, but I don't have other way. So, oh, you're gonna hate me for that. So I did draw up a view from the side of the machine. This is obviously not to scale. I have it to scale in the computer. And then I can just measure center distances between the pulley shafts. And that way I do get exact distances down to 2 decimals. I think you can increase it. Where is it? Here. 192.29 and so on. So I do have all those measurements exactly now calculated by CAD Soft Eagle, and this is for, and including the sizes of course, for the pulleys. This is here. I will have, this is the wrong pulley, I'll just put it on there. Actually, I did take this stepper out of my PNP machine, so it has a different pulley on here. So this will in the end will be what it will. This will be 15 tooth and this will be a 30 tooth. I'm having a reduction of 2 to 1 to increase torque even further. That's also NEMA 23 but 80 millimeter one. And these are my encoders that you saw before. And I finally did change the blocks here to the white ones, because the white ones, that's why I did choose them, have the exact distance that I have on this profile, so I can screw it down. Here I have adapter plate to raise it to the required distance for the ball screw nut. And I did jump something, but I don't know why or what. Anyway, this is what I use to calculate the center distances, and this is also what I'm using for the adapter plates for the BK12 and the BF12 mounts, because this has a center distance 46 millimeters, the profile has 40. So I did make those adapter plates today. I just screwed them on here for the video. I will take them down and finish them off nicely. This whole machine will get taken down again and finished up and make really nice. I don't know what I'm gonna do here, if I'm gonna make it shiny or not, but anyway, you can also see that I put covers for the profiles anywhere I can. Luckily I bought this also 5 years ago for my CNC mill and had them left over. And what I'm doing on this build also is, by changing out a belt here that normally goes from this stepper to the ball screw, it will go from this stepper to another pulley over here with a not reduction, or is it reduction? Yes, with a ratio, with a 1.8 to 1 ratio, because as you might know, a stepper motor has 200 steps, and this way I want to build a dividing head with 1 degree steps, or if I use micro steps, 1 degree, half degree, quarter degree steps, then I can dial in. So 1 step here, 1.8 degree step here will result in a 1 degree step here, which will give me 360 main degrees on the chuck. So then I can use this as an indexing chuck. What is it called? Indexing chuck? Indexing head? I think indexing head. So excuse me, I didn't make too many CNC Lathe videos, so my terminology might be wrong. This will also get covered. I will put also inductive sensor on here for threading, obviously. I mean, why would you make a CNC machine if you cannot do threading? So that will supply the pulse from the spindle to the computer, or yeah, computer. And by the way, I will use Mach3 turn on this machine. Obviously Gerbil does not have the ability to drive a CNC lathe, so I'm using the trusted old-fashioned Mach3. So anyway, here I also added a block here, which will get covered here as well. and here I will have a connection to the ball screw by angle. I'm not sure if I'm gonna use, where did I put it? If I'm gonna use this steel angle or aluminum one. I will see what will be fit best in here. So that's what I have there. And here I have the carriages that I took off here. These will be used for the tailstock. And in case, if you're wondering what these things are for, these will be, I named them because seeing them like that, I thought of the Twin Towers in Manhattan. And this will be my milling attachment, and I will call it Twin Tower Milling Attachment. So since I figured I have a bed that has 2 axes, just add a 3rd axis and have a kind of mill. Or without using this, I would have, I'm not sure yet, this was initially going to be steady, but then I can only move it here and it has nothing to do with the lathe. But if I make this movable and have the indexing head here, then I can do all sorts of machining on round stock, including the tail stock holding it, and then have this do any machining work here. So that is still, well, it's an add-on. It has nothing to do with the CNC mill. Apart from, I think actually I got most of the parts. I have the motors. I did order some stepper drivers. I will be using the DM556. I think these will be perfectly suitable. Don't get those cheap TB6660 or something like drivers. Those are really bad and burn out all the time. So get some, at least this size of drivers. And I will run the steppers of 36 volt. And here is the actually the VFD for the spindle. And I will need, yes, what I'm missing is the 36 power supply. And obviously I will do drag chains on all the wires. That's just coming out like that, but that will be hidden somewhere on the bottom. I'm not sure yet how I'm gonna do it, but I'm sure I will find a way. So this is what I have so far, and I can't wait to get this going. Here I got some covers. These will be all covered up. I don't know if I'm gonna have one cover going all the way or how I'm gonna do it, but that's all just cosmetic. And oh yeah, for the, how you call this, the tool holder, I'm going to use a solid piece of aluminum. That's my drill press. So this will get mounted on here, and then I will use the chuck itself to drill and machine all the channels. I will drill a hole in it, and I will machine a slot for the regular tool holders to be mounted here, and then drill holes here for the screws to hold the tool bit and whatnot, and one center hole here that will be holding on to the aluminum plate here. So this will be my tool post. I think it's called tool post. I was going to buy something, but I might do it further down the road, but right now I'm trying to get the money together to get this thing going. And what I have also to say is, I showed you this before. This little guy helped me so much. You can see the dust there. I had to not screw down, sand down. I'm sure. I'm sorry. Please forgive me. Those heads were a little bit too wide to go through here, so I had either the option to drill a hole here and widen this aluminum profile, which would ruin the look. So I went and sanded down 2 of the edges of the screw to make it go through there. It was only like 0.5 millimeter each side, but if I have to do it by hand, it would be not as precise and it would take forever. And this is where even a small tiny belt sander like that comes in handy. I use it on certain screws to sand them down because they were too long. And what else? I used them quite a few times. So this is really a big help, even though it's small and it might take a few minutes longer to use it instead of a big one, but it is a very useful tool. So if you don't have one, I made a review. Go get one. There are many available. This one is a nice one with all aluminum plates. The cheaper ones have folded sheet metal, and I really like this one, so I'm glad I had this. I'm also glad I had my vise to hold some things down while drilling them. For example, tapping those aluminum plates. I did drill them obviously on my drill press by using this sheet as reference, where I indicated the distances that I need and the diameters and whatnot. And I want to show you something else that I did, which helps a lot, because you might know, I'm sorry, I have to put the phone down for a second. As you might know, on a drill press you have a switch like that, and it's always on the, for me it's on the wrong side, because when I'm holding down a part, I have to, with my hand, go over here, turn it on, and then come over here to drill it. So I had this foot switch that I bought many years ago, and I just connected it to a switch like that. This way I can turn the machine on and then just with my foot start and stop the drill. And this makes it so much easier to use. It's unbelievable. I mean, it's really a big help. If you have a switch like that, you will know what I'm talking about. If not, do get one. If you drill a lot of holes with a drill press, it is a big help. And since I have it on a plug like that, you can use it for any machine independent of the machine. So I just connected the wire to the switch here. So that's how I turn on and off my drill press. And I think this was it. If you do have any questions, please leave them in the comments, and I would like to hear them. And here I want to show you, I will make a separate video on that. This is the card that I did buy, because I cannot make this myself cheaper than it is. But I will use my pendant also, and I will show you this in a separate video. But this is the controller card that I'm gonna use, including the pendant, but I will mostly use these encoders to move the what is this called, the compound slide, I think. Yes, compound slide. I need to write this down and put like small notes to it, and so I will remember for the next video. So hopefully, well, I'm waiting for parts from China, and that's gonna take a while, because initially I had these things calculated, not with Eagle, differently, and they were all off. So all the belts I have bought do not fit. So I'm using now, or have ordered new belts, waiting for those. And those pulleys I did order. I need to order another pulley for here. I did order that, but I'm waiting for it. And these two pulleys I still need to order, and the belts for it. And yeah. Actually, I want to show you just a short thing as well. Let me pause the phone for a minute.